Hi everybody, and welcome back to part 2 of programming of our development board, Blinky 2, using MPLAB. And today we're going to dig into a little bit more of programming using the Microchip toolchain, I should say, and some of the advantages and disadvantages of using a tool called the Microchip Code Configurator, or MCC. Now, again, let me reiterate that there is no shortcuts. This tool will allow you to access and set a lot of registers very easily, but it sometimes doesn't work. And knowing what you're looking at and how to manipulate it is a great way to troubleshoot it, and understand that MCC creates a lot of bulk in your file that isn't actually necessary, and so you really want to be careful not to use it as a catch-all. That it's a great way to learn how functions work, and then as you progress, you'll probably use it less and less. But it's a very powerful tool, especially for setting up your I/O pins. With larger parts, if you've got one pin like we have in this, or two pins, it's not really time saver, but it definitely is a godsend when it comes to dealing with a lot of different peripherals. Okay, so without further ado, let's dig in. Okay, here we are. I've got my MPLAB open, and one thing that I haven't been able to do is to get this to emulate, okay, with our Proteus. So we're going to skip that part, and we're going to program directly into our development board. Okay, so this should be a fairly short video. Okay, we don't need this, but we do need to create a new project. And again, this is going to be a standalone project, so we'll say okay. 18F26K22. Oops, doesn't recognize it with that extra 5. And we're going to go ahead and set it up directly to go to my snap. By the way, the snap is a low voltage programmer. As we're dealing with this, you're going to want to make sure that you do ensure that it's set for low voltage programming. These are great little programmers. They're quite inexpensive. They do have a lot of shortcomings. For example, I can't power the board from the tool the way that I can with my Picket 3 or my Picket 4. But the cost savings is astronomical. It's $20-some versus like $70 for the Picket 4. Okay, so if you're just starting out, or it's for your home, the snap it's awesome. But if you're looking to do things like programming on the go, it's not even an option. Okay, so we're going to want to set our XC8 as our compiler, and we'll give this a project name of Blinky 2. From the spell, Blinky 2. And we're going to want to make sure that it is on our, or in our file where we can find it easily. So here we go. On my desktop, I've created MPLAB test. So there's Blinky 1, and now I have Blinky 2, and I'll say finished. And same as when we were setting this up before, everything is empty in here, and that's okay. And what we're going to do is, instead of creating a file, the first thing that we're going to do is go to MCC. And this takes a few minutes as it actually goes to the internet and checks that we have the latest revision. Downloading, yes. Hey, and one thing that's new for this setup as opposed to the other one is it's looking for a it's going to create a MCC file or a myconfig file. And so I just usually leave mine as myconfig. I don't know if that's wrong. I'm sure somebody will tell me if it is. We need to go ahead and start setting things up. And so, for example, the system module has a few things that we want to make sure. As I said earlier, we want to make sure that we are set for low voltage programming. We want to use the internal oscillator, and we want to make sure that we have our function pins on our two outputs. Where are your internal oscillator block? We want to set this to 8 megahertz. Okay, and that should be good. And then we're going to go to our pin mode, and you'll notice that there's nothing in here. We have this beautiful display of our chip, and we have this little register across the bottom. And so what we can do is we can actually start to toggle this stuff. For example, pin RB, let's not do that. C1, we want to set that as an output, and you'll notice that it toggles over here. Come here, you. And we also want to set A5, okay, as an output. And they come up on here. We want to make sure that they're all set as digital, as outputs, and we can give it a name. In this case, we can actually call this one red, and we can call this one CCP. We can also go ahead and determine whether we want it to start out as high or low, and this is a lot of the registers that we were playing around with previously in the defines. Okay, and so when we're all finished, what we need to do is we'll go to generate, and this will create all of our files, including the main file. And when we're finished, we can say close. We can then go to our project or our files. We can get there either way. And you'll notice that under our source files, we have a new directory called MCC generated files and our main. And if I open up my main, there's lots of white space in here, but it has a function called system initialize, and inside our main loop, and it includes our MCC generated files.h. Now, if we open up our directory here, we can see that there are 3 files that are created. The device config has a lot of, well, basically it is what we copied and pasted into the top of our program when we made our Blinky 1. We have the MCC file, which includes our oscillator functions, and it includes this pin manager, and the pin manager has the lat, the tris, and the ansel. And so basically nothing that we haven't seen. Weak pull-ups, I mean, that's something else. But what it also does is this little CH button up here opens up a header file. The header files are great because we can put in a bunch of functions, okay? And one of the defines that is created here is it's created, for example, CPP lat and red lat, okay? And we can call on those from our main function, okay? And so in here, why don't we go ahead and write ourselves a quick little function. And so here we want to say we're doing the same as before. So red underscore lat, oops, equals 1, right? And the other one was CC. No, let's do it right. CCP underscore toggle. What's CCP underscore toggle? You'll notice that there is a toggle, so we can set high, we can set low, we could set the lat. CCP toggle actually takes the bits and toggles them. Uses the tilde instead of the exclamation mark, but as we're dealing with a bit, it's virtually the same. And so, okay, there we go. And underscore delay ms, and this time we'll do 250 milliseconds. And that's pretty much our program. And so we can go ahead and we can program this. All right. Let's actually take a look at that again. Red underscore lat. Did I misspell it? Well, let's try putting this in, see if it's more happy. That's got it. All right. So, so we've set red set high, and we've set our toggle, and let's go ahead and program that. Updating the firmware, of course, has to do all of this background work. And like I said in the previous video, it's nice that it does it. It's a little bit annoying the first time around, but it ensures that it has the latest firmware. And there we go, the program is complete. And I'll go ahead and pull up my waveform here. And here we go. Come on, you. So we're set to 250 milliseconds, 1, 2, and a half, we'll call it. And that seems okay to me. All right, so as you can see, it's super fast and easy to set a program up this way. The MCC, we can talk about that a little bit more if it'll load up again. It takes forever, it seems, especially when the record button is on. Hey, there we go. One thing that we could talk about is available resources. And so all of these tools are available here. So you've got simple things and complicated things all tied in. So your analog to digital converters, your digital to analog converter, your USART, some memory stuff, your MSSP, your ton of timers. And what I'm going to do is I'm going to use MCC, and we're going to build up our project step by step and start to bring in some of these tools. Okay, and so all right. So the rest of the videos that I'm going to do, we're going to build up the development board program. We're going to start to look at the analog to digital converters as well as the timers, and build up the I/O. And I hope you give me a thumbs up. Do subscribe so that we can give you updates as soon as these modules are finished. And thanks for your time. All right. Have a good day.